Hello, everyone. Welcome to Data Centrifuge, cleaning data for reliable insights. My name is Molly Purcell. I am the digital marketing specialist for Greenbook. It is my pleasure to introduce our speakers, Lev Mazin, CEO and co-founder of AYTM, and Dale Gillum, Director of Product Strategy for AYTM.
Hi, everyone. I'm Lev. Start this conversation today about what we call Data Centrifuge project. It's going to be a conversation about data quality, a very scary topic for many of us. So I hope that knowing that, subscribing to the session, you have brought with you your comfort blankets and are ready to continue. I suggest that we start with a quick check of our relationship with data quality. Please take this one question poll when you can. The sooner the better. You can follow the URL that is in our chat window of the session, or just scan it with your smartphone. In the meantime, I would like to give the mic to Dale, who is one of the smartest people I know and has been doing this for many years, being a data scientist. Dale, please share your opinion and your view on data cleaning.
Yeah, thanks, Lev. Hi, I'm Dale, Director of Product Strategy at AYTM again. So I actually started out my career in market research as an analyst, and I've had to perform data cleaning on a countless number of surveys. So if you've had to clean a data file before, this may sound familiar to you. But if you haven't, here's what often happens. So as a human analyst, I would say it's really more of an art than a science. So a lot of times you may start out with some prior assumptions and rules, but once you get into the data, you find that you have to adapt your thinking and adapt to what you're seeing. So while you're in it, the challenge is, how do you know how much cleaning is enough? I've described it before as being like cleaning a cast iron skillet. So obviously you want to get the food particles out of there, but trust me when I say from experience, you can over clean a cast iron skillet and totally ruin it. I think the analogy fits, because if you over clean your data, you can actually create some bias if you've cleaned out some good respondents, and you can ruin it that way. So when you're in it, typically you'll start with something like, say, 3 flags. If you had the foresight to set up some trap questions, even better. So you'll have 3 flags. Anyone who fails more than 1, you remove. Simple enough, right? But once you get in, you start looking at straight liners and open ends for some obvious bad behavior. But if you have, say, multiple grid type questions, say 5, how do you count those and how do you create flags? Is it one more flag per straight lining grid question? Depending on how you answer that question, and the same goes for open ends, depending on how you answer those questions, you could wind up with 12 to 15 flags. And now you don't know where to draw the line. And some of those flags, maybe even vary in importance. So determining how to read those flags and clean out the obvious bad actors and inattentive respondents, that's why I say it's more art than science. It's more like reading tea leaves. And as an analyst, what you're trying to do is you're trading off 3 things. You're trying to make sure you've cleaned out the obvious bad actors. You're trying to make sure you haven't over-cleaned the data, like I mentioned. But also, you're trading off the labor cost and time of continuing to search for that next bad behavior. At some point, you have to call it done. You've done your due diligence, but you never really know if you've done a good job. That's the challenge we're trying to solve. So I'll hand it back to Lev to review the results of the poll and talk about what we've developed.
Thank you, Dale. Can you see the results of the poll, by the way?
Yes.
Okay, great. So thanks for answering. For those of you who said that you hope that someone does, I commend your optimism. Those 16.7% who know exactly who does it, I wonder if you know also how they do it. because it's as important as knowing who does it. Those of you who said that you do it personally, I'm happy to see such a high % of people participating this this presentation. I really encourage you to get in contact with us and help to push this topic further, because with your experience, with how you do it on a regular basis, together we can improve this this method and approach. But let's get back to the presentation. And let's talk about various ways that we as the industry are looking at data quality. So I want to make sure that it's clear that we're not talking about panel quality, which is incredibly important. I hope that when you select your panel partners, you're looking at those who are providing great care and attention to how they collect the data. What we're going to be talking about is separate from that. So let's talk for a minute of what it is not. Paid Viewpoint is a panel site that we built from ground up. We are very happy with a great reputation rating that it received from the respondents in communities like Survey Police. It's been rated for #1 over years. And when you select your partners, they can, and we do many things on that side of the equation to make sure that the panelists pay attention, that they're well treated, that their experience is great, that they're not managing several accounts. All of those technology and logical quality verifications are going into the daily operation and building of a quality panel. And one panel varies from other, but the more tools we got in our arsenal, the more robust all of that process becomes. And then if company like AYTM also has the benefit of controlling the survey environment, then that part can provide care for making sure that the surveys are presented nicely on mobile devices. They're not too long, their experience is great, and providing overall the safety net for you as a researcher, not being contributing to bad data. Altogether, we see a very healthy data quality coming from our panel, right? It's less than 1% of respondents that we see being rejected by our clients and our admins. The problem is that none of us can solve the fielding problem by ourselves. We all are calling our partners, we call our API partners, you may be engaging other suppliers, and we don't have direct relationship with the respondents on the other end of that transaction. So how do we tell if the quality of their responses is good or bad? And here's where I want to draw the line between panel quality and responses quality. This session is about focusing on the data that we have in purely survey responses in raw data, and what can we do to assure that it's of high quality. This is not going to be a rant of, oh my God, this is very, we're in such a bad shape. As I heard over and over for the past 10 years, this presentation will show, will demonstrate what can be done and what we are doing. So when, as researchers, we look at our data, we see pretty charts, we see visualizations, and this is our job. We want to focus on that, right? And we're kind of scared of taking a flashlight and looking at the monster under the bed. However, it's quite past due and quite important for all of us to get that courage and look at the raw data and look at it critically and make sure that it's all good. We decided to call this project Data Centrifuge. It's not a feature. It's much larger. It's a multi-month endeavor that we decided to start, and it's something that, frankly, such a magnitude of a problem that we can't solve all of it ourselves. So we need your support, your involvement, and entire community we're a bunch of very sharp people. There's nothing we cannot solve. So let me share how we get here and what is already done. First of all, why we chose to automate data cleaning. For several reasons. One, it's pretty time consuming for researchers and statisticians to do it manually. Second, it's sometimes it's pretty easy to overlook an important issue, even if you are an experienced researcher like Dale. And thirdly, there are a scope of issues that are not visible to human eye, no matter how experienced they are and how much time they have, while computers and algorithms can do it. And the last one is, look, we were the first company in 2009, over 10 years ago, to show the industry that you can do survey people automatically in fully DIY fashion. You can combine both the survey platform and community in one solution. And ever since, we've been pushing the boundaries of market research automation pretty methodically, year after year, rolling out the max diffs and conjoints and other techniques. And we feel that it's a good timing to catch up the quality to apply the same principles, philosophy, and methodologies to the quality of the sample as to the speed and ease of running those tests. Why Centrifuge? I'm sure that all of you know what Centrifuge is. It's a mechanism used in science often to separate different fractions of a liquid to put the heavier stuff separately from the lighter, typically in liquids. And I thought that it's a good name for what's going on here. This is an interface. I will try to share it at the end of this presentation, but essentially we're trying to run a machine that will separate the high quality, denser completes that we want to focus your attention on from lighter, shallower responses that are that don't have that high quality. What it is and how it works. Data centrifuge is a family of data quality vectors. You can call them dimensions, you can call them approaches. We decided to call them vectors. And each vector is a methodology, it's a statistical method. It's in several cases, it's a full neural network and what is called artificial intelligence. In some cases, it's Bayesian network, and others, it's other sort of statistical exercises that we run dynamically on the set of survey responses. But then each such metric, each such vector analyzes all the data, comes up with scores for responses, and then feeds it to the larger set of algorithms that look at all the signals and make a judgment about each individual response. So let's go over those vectors. Let's start with most obvious, junk open-ends, right? It's most obvious because any intern can read the open-ends and make a human judgment if they're high quality or not. And obviously, first, most visible thing is some gibberish. Then there is a class of open-ends that are not very informative, not very high quality or thoughtful, but they could be legitimate, right? You don't want to reject entire response normally when they say that it's okay or I don't know or not applicable. Sometimes you do, sometimes you don't. But it's time consuming. It's also prone to subjective judgment if several people are doing those open-end data cleaning. Instead of that, a better solution that we are developing is NLP Neural Network, right? That is trained on survey respondents to identify those gibberish, junk, or not very helpful respondents and mark them appropriately. By the way, each vector is not binary. It's issuing a score from 0 to 1 that increases or decreases the likelihood of response being not very good. The next one is speeders, right? It requires some statistical knowledge. It requires you to look at the numbers, It requires you also to get the information about how long it took for someone to take the survey. However, in most cases, what we get is the total length of interview for each respondent. And the rule of thumb here is that, look, just take the shortest ones, find where it's reasonable to draw that line, call them speeders, you'll be better off, right? Unfortunately, there are many situations when it could be detrimental to your data, not beneficial. So, for example, if the survey structure was pretty complex and someone took a very short route because of honestly answering the questions, they may be very high quality respondents. They may be answering those few questions very appropriately, and you want their answer, but they will fall into the speeders column. And someone who's speeding through without reading anything, they will be in the safe normal distribution of longer survey responses, and you will miss it. Another problem is that people are dialing in on different speeds of internet. And if you're not considering the time it took for question to load versus the time it took for them to reply, you may be penalizing people who are just on faster internet. And the solution is pretty difficult to achieve if you don't have that information, but we have the benefit of knowing exactly how our platform operates. So we take a microscope. We look at every minute detail that goes into every question. We know exactly question types. We know how many characters are there in the question. We know whether or not there was an image, how many answers, how long were their answers, what's their open end or not. And we arrive to a very precise prediction of what we consider to be reasonable to thoughtfully answer this question. And it's based on our historical data of all the surveys that were ever run on the platform and some expert opinion. Then we look at what really happened, and we draw this correlation, and we see people who were just too fast to be believable for taking the survey, but the survey consists of questions. Every question is a separate unit. Every sub-element of every question is playing a role in this model. And that's how we approach the speeders. Straight liners is even tougher because yes, if it's once A1 on every question, you can spot it in the raw data. But what if respondents start, playing tic-tac-toe in the questions or drawing diagonal lines or something like that? It's much harder to spot in the raw data for a statistician. Not impossible, but pretty difficult. One thing that you will need to do is to unrandomize the respondents, because you need to know what order they saw if every set of answers or sub-questions, and not always you have even access to that information. The solution is to create a pretty fantastic, interesting model that looks at the consistencies or inconsistencies of the lines that respondent is taking. Like if they are repeating the same pattern over and over, they will be drawing those lines. And when they're changing something, we will record a turn in their behavior. And we'll calculate the ratio of those turns versus continuing on along one of the many patterns that we check on, and draw a conclusion from 0 to 1. Duplicate responses, right? I'm not talking here about IP addresses or digital fingerprints. All of that is handled by various systems that we saw in the industry for many years, and we have our own superior graph tool that looks for respondents' duplicates. But sometimes smarter respondents got through. And this is a pretty sophisticated way of catching similar looking answers and not adding to that list someone who just answers in a common way. Because if you have 3-question long survey and every question is obvious, guess what? Majority of your respondents will be duplicates from the perspective of how closely they answered the survey. This, our solution to this, looks again at the structure. It creates a Bayesian network to see what is normal for the survey, where the mainstream is, and if it's something unusual, but a few people are going the same path, that raises the flag for it to be a duplicate. Random responses, also pretty practically impossible to find random responses in randomly looking numbers, but machines can help us to do that, and this is exactly what we do. We calculate the difference between sample and random chance of answering in a particular way and highlight that as a suspicious activity. I like this one. It's exotic responses. We look at the common issues here is you can run your crosstabs all day long, but it's incredibly time consuming to find those outliers. And with Bayesian Network to the rescue, it allows us to find those cases when a person is, for example, lactose intolerant, but at the same time they claim that they consume milk products regularly. Something that computer doesn't understand, but it understands that it's so rarely seen in the survey across other respondents that either this person is really unique or it's worth looking deeper at what they are and what they do. Inadequate image responses. It has to do with receiving thousands of images and looking at them and in an effort to find those images that are either the same or look very similar or inappropriate or stolen from Google. All of that is, again, if not completely impossible, incredibly difficult to spot. If a person is answering survey from different accounts and they have the same toothbrush and they take photo from different angles, machine can find those similarities and highlight it. Human eyes in a scope of 1,000 similarly looking images really can't. And not only we find similarities, we go and check if an image was posted somewhere outside of on open internet. We look for stock photography with white background. We look for warning signs of inappropriate content and things like that. Interrupted sessions is another thing. We look at situations when respondent received a stimuli or a set of questions, went on around their day, came back to answer the questions. Obviously, the stimuli will evaporate from their heads, and you don't want to penalize someone who just stepped out to grab a cup of coffee if the situation allows that. If they were just on the traits part of the survey, to be more precise here. There is a host of other vectors that we're preparing and thinking about, such as incorporating the custom red herrings that researchers have, checking the digital body language of respondents, and looking at the Bayesian feed deficiency on the data sets that utilizes it, like MaxDiff and conjoint. And if technology permits, I would like to show you a little bit of the interface and how we look at it, just to give you a taste of how we are implementing it. While I'm doing it, Dale, maybe you can share some thoughts about this whole project.
Oh, yeah. Well, whenever I first heard about it, I think the first thing I was excited about, wow, it's already loaded, but I'll finish what I was saying.
Thank you.
The thing I was most excited about was the straight lining, and I think it's like it's simple in its complexity. If someone had asked me, did you check for if someone was going in a diagonal, I would have had to bow my head and say no. Unfortunately, that would have taken way too much time for what it was worth. So that was my favorite one.
Thank you. So in this interface, I can check different vectors and what they captured after survey was completed and we got results. And then I can see the individual issues that were each vector found. But what I really want to concentrate is on the overlaps. For example, currently we're looking at straight liners and speeders. Those two vectors caught a bunch of suspicious activity, which may be okay, and they could be over paranoid. But when I see overlaps, there's a stronger signal for me to look deeper into them. And let's say I want to add duplicates to the mix. That becomes kind of a triangle of sin. And I can continue and look for exotic people and random responses and interrupted sessions and finally open ends that were suspicious. By the way, in this case, the survey was about pet surveys. And we asked in one of the questions, please give us the name of your pet. And since most of the names of the pets are made up, our system couldn't find them in the dictionary and highlighted them as suspicious. And good thing we're not scrubbing this cast iron too deep because we would falsely accuse many people with funny named pets as liars or providing junk open ends. And then you can look at a particular set of respondents, identify them, filter, export, and look them into teeth and see if they're really that bad or if you need to fine tune it. There's a different grade at which you want to draw that line, and every grade will give you various kind of settings of sensitivity to issues that may have happened during the fielding. This is what I wanted to show you in this demo. It's and in the rest few minutes, I would like to talk about the future and the current state of this technology and how you can participate in moving it forward. So going back to our deck, the frequently asked questions that I can think of, how is it different from what exists? In the beginning, I spoke a little bit about the difference between panel quality and survey response quality. I think with this way of looking at the problem is way more challenging technology-wise, but it's also much more independent, and it's available and accessible for those of us on the receiving end of the data. And that makes it much different. How it's why are we saying that it goes beyond AI? I have a lot of respect for neural networks, but we are going deeper in minute details. We're using instruments that are more fine-tuned and exact, in addition to more a generic AI that is kind of a black box. You put data in, you receive data out without exactly knowing what happened there. How will it evolve and improve over the time? I don't see it as a silver bullet that will solve all our issues. There will be smart respondents who will be doing bad things and will always be thinking about ways to improve and calibrate it. So if our clients would come to us saying that, look, we found some bad completes that your system didn't, that I would say, awesome, let us examine them and make our system smarter. And vice versa, if we overdone it, that's also incredibly important for us to know. And state of project philosophy in the future, we started with those 7 vectors. We are very proud of how they operate. We're currently in the calibration mode. We're looking at our surveys through the lens of those filters and gearing up to the future where we'll be utilizing it routinely on every survey crossing our platform. What's the impact on the industry? I think that together, eventually, we have a chance of arriving to some sort of a standard of what we all can reliably call a decent quality response, and what is absolutely beyond reasonable doubt is a bad actor or bad response. And it will help us. It will help us to increase the quality, to not worry about it, to focus on the insights. I think that it will help the technology to solve some of the issues that it may have created by speeding up everything in the past several years. And I hope that on the emotional level, the data quality will become more of a friend than a monster under the bed. We can all make friends with it and just happily continue going about our research journey. I welcome everyone to join us in this conversation, in this endeavor. The next time we will be publicly discussing it will be at the Insider conference later this month. I would love to have as many conversations with you as possible. Thank you.
Thank you, Lev. Thank you, Dale, so much for your presentation. I think we've run out of time for questions, but if anyone would like to reach out to the two of you, they can do so in the community section of the IIEX agenda page. Thank you again.
Thank you.
Thanks.